Hey everybody, happy snow day. I am going to do some chapter 7 notes for you. So chapter 7 is called Linear Regression. And linear regression is just a fancy name for line of best fit. And line of best fit is related to our scatter plots from chapter 6. Okay, so in chapter 6, we made scatter plots. So let's remind ourselves. That's two quantitative variables graphed at the same time, and we were looking to see if they were linear. Okay, so that's the important part that we want to focus on, the fact that we were looking for a linear relationship. If we focus on that, then making linear regressions or lines of best fit for the data that was strong and linear, not weak or moderate and nonlinear, would make a lot of sense, okay? So the idea here is that we are going to take the data that we might have seen in chapter 6 and attempt to fit it with a line of best fit. So we call our line of best fit a linear regression model. Okay, so I'm just going to tell you that is the line of best fit. Okay, so a linear regression model, way back in algebra, you knew that as y equals mx plus b, right? Where m is your slope and b is your y-intercept. Okay, so we are going to use our calculator to find a linear regression model. Many of you have actually done this before, but we use different notation because it's just a model, okay? Which means that we are only estimating what these values are. We have actual data that we graphed, so we know what the actual y values are. We want to make a guess, so we note that with this little hat on top of the y, it's literally called y hat. So if you email me and you know I can't type out symbols like this, I'll use the term y hat, okay? So that's how I'll say that. And this little guy up here, that symbol, literally means estimate. So that little accent, whenever we see it in this class, will represent a guess for the y value. And then the notation we use, we just replace slope and y-intercept with different letters. It looks a little bit crazy, so bear with me. It looks like b1, so b sub 1, x plus b sub 0, okay? But I just want to be clear, hold on, I've got other colors right next to me, that this is just another way of writing slope, and this is just another way of writing the y-intercept, okay? So we've got b1 and b sub 0, but they just stand for slope and y-intercept, all right? Now, one thing that we have to do is, sorry, that's my dog, interpret the slope. Okay, so I want to remind you what a slope really represents. It represents rise over run, right? Or maybe you've seen this notation back in 070, delta y over delta x. This is the change in y over the change in x, okay? So the way the slope is described is that for each additional x variable, right, the y variable, and then we have to choose increases or decreases by, and then you plop the slope number in, the value that goes with the slope, okay? So if this was like 2, right? And then let's say these were miles per gallon, so miles over gallons. So for each additional gallon, right, miles per gallon, that'd be terrible, the miles increase by 2, okay? That's how you would describe that based on the units that are given. I will do an example in the other video that I post with examples from the packet. So it'll be 2 separate videos so that they're nice and clear, okay? And there's literally one other concept in this chapter that I want to show you. So I'm going to scoot this up a little bit, and I'm going to do the final concept, which is called residuals. Okay? And so residuals are the literal distance between the model, so our line of best fit, y hat, and the original data. Okay? So I'm going to show you what I mean by that in a little picture. So I'm going to draw a little picture right here. It's like just a scatter plot that has only 2 points on it, to be really clear about this example. So I'm going to put the x and y axis here, and I'm going to draw you, right, a y hat, okay? So here's y hat, and I'm going to put this point right here, okay? So this point is any value, let's say, above the line at x comma y, all right? And if we're looking here, then what we can see is that if we drop a vertical line down to this actual y hat, that we have another point, x comma y hat, right? I never changed x, I just used the same x value, and I'm calculating the estimate at that same point, okay? So we've got two different y values. Well, the residual, which we used the letter E to represent, okay, I know it's strange, but we use the letter E. It's usually like an italicized lowercase e. Sometimes they bold it in the online homework. And we take the y value and we subtract the estimate. So we take the actual and we subtract the estimate. So I'm going to give it to you in words so you understand. But I'm finding this distance right here. This is E, okay? I take y and I subtract y hat, all right? And if you do that in this scenario, this is a large number minus a smaller number. The value I end up with is a positive residual. And look at what that does. This point is above the line. And if this is my estimate, then this is considered to be an sorry, my dog is chewing on a bone right next to me. This is considered to be an underestimate, okay? So that's because my line, estimate right here, y hat, is below, under the actual data point. So let's flip the script. If I put a point down here, still x comma y, and then I try to connect it to this line right here, my point is still going to be x comma y hat. But now, when I take y, which is a smaller number, and subtract y hat, which is higher, I will end up with a negative value. So I'll get a negative residual. Oops, you know I don't know how to spell. And that is actually, where's the line? Over the point, right? So that's considered an over estimate. Okay, and those are literally all of my notes for chapter 7, just one little page, okay? So what I will do is I will take a picture of this, convert it to a PDF, and I will post it under the video, so you have this access as well. And then I will also create a video with some examples for chapter 7, so everybody can do some of that work from the packet from home. Enjoy your day.